important part of our fourth release, the Cervantes release, which is due in March. Generally, what we do is that we go over the theory, we go over the math, we select the appropriate papers, we create a design, then after we create a design, we create mock prototypes, and then we proceed with development. And you're familiar with our development process. We do open development, where everybody sees everything as it's being developed. You see the iterations of the interface, you see the iterations of the code. We go to testnet. Once we have a critical number of features, we might do a couple of testnet deployments if the release is really big. Then we do some regression testing, and finally we launch on mainnet. And it's been done for the Neruda release. We are doing it for the Para release. We are about to go to mainnet with some additional changes, and after that we go to Picasso, which is our augmented reality release, and then Cervantes, which is our online ad distribution release. So I wanted to go over a small blog post that I wrote, which is going to be it can be taken as an introduction for an upcoming paper for Cervantes. This is how we solve online advertising. So the first thing that we do is that we calculate the value of attention. The value of attention for e-commerce, it's essentially the probability of conversion. So let's say you have a web page, and the web page is very well designed. It's a very, very well looking web page. The probability that that web page will convert is higher than the probability that a messy web page will convert, because a very nice crafted, very nicely designed web page conveys some respect, some trust, and that trust will yield better conversions, right? So what we do online is basically take that attention and turn it into conversions. That's what advertisers find value in the monetization of online traffic. So this can take three avenues in Bitfari. The first avenue is that you're showing an ad on a screen, a digital screen or a billboard. The second way in which it can happen is that you're getting value from a click. And the third way in which it can happen is that you're getting value from a page view. So here you're only seeing a page, but again, the person might have bought something in his home computer, or maybe they just saw the ad online and went to a physical store. Here they are seeing the ad on a billboard or the digital smart TV, and here they are making a click. So for each one of these cases, the equation will be different. And instead of just writing like the whole equation, I just decided to put this as functions so that you can get an idea of how we are calculating the probability of conversion for each and every single one of these use cases. So if we are distributing ads on digital screens, the size of the screen, it's an indicative of how much attention it's going to get. If you're seeing a bigger screen, you might give more attention to that bigger screen. It might not work for a single person, but if you look at the numbers on an aggregate, society as a whole, the bigger the screen, the more attention it gets, right? There's another thing to be said about the location, right? If you're seeing a screen in Times Square, that screen is more valuable than if you're seeing a screen in a rural area. So we just use area for that, okay? Area or location of the screen. So the better the area, the higher the value of that conversion. Maybe a screen is placed in such a way that it gets better attention because it's just placed inside a shopping mall, where people are more likely to buy whatever you show them because they are already in a shopping mood, right? So location is also a component that is not necessarily listed here, but we included in this area thing. So time. How long are you seeing this ad for? So if you're seeing this ad for 10 seconds or 1 second, if you're seeing it for 1 second, maybe you don't remember it, right? If you're seeing it for 10 seconds, maybe well, I saw it, but I don't know. If you're seeing it for 30 seconds, then you are seeing a big enough chunk of time of the advertiser's message. You're getting so much information from this ad that the likelihood that you will convert for this ad, if the ad was skillfully made, is just significantly higher. So time is another factor in this equation. And then finally, the medium. The medium will yield a particular type of attention. So if you're seeing this ad on your computer, you're probably sitting down, you have a lot of time. If you're seeing it on a billboard, you might be driving, you don't have as much time. So if you're seeing an ad on a billboard, the nature of the attention that you're giving this ad, it might be an attention that is, we can characterize it as branding. Okay, it's good for branding, maybe not as good as an online ad that you see on a computer for conversion purposes. So we calculate this probability of conversion in this case as a function of the screen, the type of screen, the type of the ad, the area in which the ad was shown, this is zip code, and the medium in which the ad was shown. Was it shown on a computer? Was it shown on a billboard, a smart TV, etc. Right? So if you're seeing an ad on a billboard, we are using this function to calculate the probability of conversion and hence the value of this attention. Okay, and this probability of conversion will yield a value in FARIs. So this is more or less the intrinsic value of the FARI, the probability of conversion that this attention yields. Now let's go for the use case of clicks. Now you're seeing an online ad and you're paying per click, right? And we are charging for the number of clicks. We are charging for the page in which the user made a click. We are charging by the keywords that that page contains. Then the equation gets simpler. We just use the average website conversion rate, and this will get an intrinsic number of how skillfully made the website is, right? And then we just get a value of the keyword. We take this from a table. If you're looking to buy a car, that keyword is more expensive than if you're looking to buy toothpaste, because cars cost tens of thousands of dollars and toothpaste costs less than $10. So the value of a keyword for a car purchase is just significantly higher than the value of a keyword for toothpaste or any other small ticket essential items. So we take that into account for the probability of conversion. Why? Because it's less likely that a higher price ticket item will sell. So you can put that into that probability calculation, and then we take the number of clicks. If a lot of people are clicking on a page and the page is hot because there's a promotion, then the likelihood of conversion is just higher. Okay, so we use all of that, and then we calculate the probability of conversion. So if you go to a page and that page is a hot page, a lot of people are clicking on it, then the clicks on that page are gonna be more expensive, right? Because it's more something more desirable. It's more likely to convert because more people want it, so on and so forth. So here you see that we are taking into account different factors to calculate the value of the attention. But again, it's as simple as this one. Here we're taking 3 parameters. Here we're taking 4. Okay, so finally, if you're paying for page view, right? So some people like to pay for page view because it yields a branding effect, and sometimes people are just patient, and they like to pay for page view because that they can build traffic that way. They might run ads on their pages, and then they make money from those ads. So they don't necessarily want to pay per click. So here we take into account the number of visits, the pages themselves, and the keywords of those pages. And the probability of conversion is calculated as the average website conversion rate, the value of the keyword, and the number of views. Right? So here we use the number of clicks, and here we use the number of views. And here we have these three equations that will yield the same result. Well, we put all of those on the table, and then we run some algorithms on all of them, and then we can tell you which one will be the cheapest way for you to actually advertise. And that's how we make advertising recommendations, right? We can tell you if you do a pay-per-click campaign, it's going to be cheaper than if you do a digital. If you do a a number of visits campaign, that will be cheaper than doing a digital. But if you do a digital, it might be better because it will raise your number of clicks. So it's just three ways of calculating the same thing, and all of this ties into my blog post about crypto ads. So a crypto ad is a new Web3 primitive. A lot of people have been raising questions about this, so I just thought, why not make a video about it and just sort of clarify the key questions that people have about this blog post. So just consider a chain swap, an atomic chain swap. So you have two blockchains. This is blockchain A and this is blockchain B. This blockchain is money and this blockchain is attention. So we're gonna trade attention for money, all right? And the way this works is that the attention chain is the fatty chain, and then the money chain could be Bitcoin or whatever, right? And then this user has a key, they have attention, they send the transaction with the key, and then some time is going to pass, and notice it doesn't happen at the same time, right? When this transaction comes back, then the money is credited once the attention was turned into money, once the attention was actually calculated as a money swap. And this is the money swap. Here we take attention, and here we have probability of conversion. With probability of conversion, we can calculate the value of the attention, meaning how much money you have. So the FAT is measured in number of screens, number of attention, number of foot traffic, number of page views, number of clicks, right? Attention essentially. But the probability of conversion is the missing link between money and attention. Hopefully that's clear. So when we apply this equation, we go from this chain and we do a swap to another chain, right? What is missing to make the swap is the rate of exchange. The rate of exchange, it's given by the probability of conversion. If the probability of conversion is 0.5, you take everything, you divide it by 2. If the probability of conversion is 0.25, you take everything, you divide it by 4, right? Hopefully that makes sense. So in this swap, what we are doing is creating a native currency by a screen time currency. The screen time currency is the FATI, screen time. That screen time is a simple measure of attention. If you wanted a more sophisticated metric of attention, you could use screen time area medium, right? Screen time area medium, which is what we use. Screen time area medium, which is the metric of attention that we use. But you could also use screen time. Screen time is also a metric of attention. It's not as sophisticated as taking into account the medium and the zip code, but this will probably work, right? So that's why these two types are listed here. So we calculate the attention and then we swap it for the native currency, which could be Bitcoin or whatever. Now, what we are using as native currency is the FATI, and that's how we give the FATI these two values. One value of the FARI is the attention that it can get, and the other value is a value of as a currency, right? Which is the equivalency of a stacks value or a Bitcoin value or a dollar value, right? Which is right now about 70 cents in dollar terms, or point 28 or point 30 stacks. Okay, so instead of managing millions of fungible tokens, like a fungible token per screen, we just manage one, and that token is the FARI. And then the paper just goes on explaining how to use this for the click use case, how we use the token to actually deter click fraud, and the solution is just to charge per click. So if you charge per click, like if you do an application, a browser, and every time you click, you have to pay for that click, then what will happen is the spammers will not click on ads because it's costing them money. The way in which we do this, or the way in which we are thinking we're going to do this for the Cervantes release, is that we are going to release something called click token. It's not going to be the FARI per se, but it's going to be like a derivative of the FARI. It's going to be a token that will be issued to people every time they install the browser, every time they use it, after the browser validates that they are human. So you will get a very basic number of clicks, and then with those clicks, you will have to spend those clicks every time you are using a website, right? You could also change like a very minimal, very minute amount of FARIs. So you can also do it with the FARI and charge very little for it, and then in this way you are also placing some value on those websites visits. So there's no way to fake clicks with this approach because it will cost the spammer money. So we decided to do it with a different token. We get more flexibility with that because we can create a token that cannot be transferred or purchased. So that's the way we wanted to do. It's a non-fungible token, but it's also a non-transferable token, a non openly transferable token. It can be transferred from the minting agency, the central minting agency or smart contract, to the user, but it cannot be swapped or transferred across chains or across users. Hopefully that makes sense. So if we do that, then we can just reduce the number of fraudulent clicks dramatically, and hopefully this is understood. So I will advise you to just look at this page. I will leave a link down below. I posted this back in November, but this is something that we have been working on since May, and this is only like an intro. We are gonna do a paper on this, and after Cervantes is released, we are going to do a beta, and after the beta is deployed, hopefully I will do a follow-up video and I will tell you there's no click fraud with this solution or with this architecture, right? Which is what we are hoping to achieve with this new technology. So very exciting stuff. Now you know how we trade time and attention for money, and how you know which primitives we are using, and how now you know what a crypto ad is, right? All right. Thanks for your attention, and remember to always